Alright, example 1. Determine the nature of the roots of the following curves. So for 1a, x squared minus 2x minus 1, this is a quadratic equation. And to determine the roots, the nature of the roots, we look at the discriminant. So your discriminant is equal b squared minus 4ac. So here your a is 1, b is negative 2, c is negative 1. So b squared minus 4ac, we will get 4 plus 4 equals to 8. So this is bigger than 0. So since the discriminant is bigger than 0, the roots are real and distinct. Alright, so that's for 1a. For 1b, equation is 2x squared minus x plus 1 equals to 0. So the discriminant, we're looking at the discriminants because we want to determine the nature of the root. So discriminant is b squared minus 4ac. Your b is negative 1, a is 2, c is 1. So I would have 1 minus 8, negative 7 less than 0. Right? So since the discriminant is less than 0, there are no real roots. Alright. So for 1c, the equation is x squared plus 16 equals 8x. x squared plus 16 equals 8x. So you notice that for this equation, the right hand side is not 0. So you have to make sure that it's equals to 0. So we get the quadratic form, general form of the quadratic equation. So x squared minus 8x plus 16 equals to 0. Only when you get into this form can you determine the value of a, b, and c. So again, we look at the discriminant because we want to see the nature of the roots. So our discriminant is b squared minus 4ac. b is negative 8, a is 1, c is 16. So I will have 64 minus 64 equals to 0. So since the discriminant equals to 0, so there are real and repeated roots. Or you can say there's only one real root. Or sometimes they call coincident roots because that's the same, coincide. Right, so there's 1c. Okay, move on to 1d, the next example. This is a given equation, x squared equals to 3x minus 4, x squared equals to 3 minus 4x. So when we simplify it, we write it to be x squared plus 4x minus 3 equals 0. So this is the general form. So your discriminant, okay, we are finding the discriminant because we want to determine the nature of the roots. So discriminant is b squared minus 4ac, b is 4, a is 1, c is negative 3. So I have 16 plus 12, which is 28, and that is more than 0. So since the discriminant is more than 0, the roots are real and distinct. Alright? And example E, x minus 2 squared equals 3.